everyone. Welcome to science class. Today's concept video is from your new chapter, Fun with the Magnets. In this video, we will explore what magnets are, how they were discovered, different types of magnets, magnetic and non-magnetic materials, and the poles of a magnet. Watch carefully, think along, and be ready to share your thoughts in class. Let's begin with the most basic question. What is a magnet? A magnet is an object that produces a special force called magnetic force. This force can attract certain materials like iron, nickel, and cobalt. The space around a magnet where this force can be felt is called the magnetic field. It is important to understand that not all materials are attracted to a magnet, only specific ones. Have you ever seen a magnet attract a metal spoon, but not a wooden pencil? Why do you think that happens? Discovery of magnet. The discovery of magnets dates back to ancient times. It is believed that a shepherd named Magnus in ancient Greece noticed that the iron nails in his sandals were being pulled by a special black rock on a hill. This rock was later named magnetite, and it had natural magnetic properties. From this legend, we get both the name magnet and the earliest known example of magnetic material. Here's something to wonder. If you had lived in ancient times and found that rock, what would you have thought it was? Types of magnets. Today, we use two main types of magnets: natural magnets and artificial magnets. Natural magnets, like magnetite, are found in nature. However, they are usually weak and irregular in shape. Artificial magnets are man-made. These magnets are stronger and can be shaped into different forms, such as bar magnets, horseshoe magnets, ring magnets, or even disc magnets, depending on their use. Artificial magnets are more commonly used in day-to-day applications because they are more reliable and can be customized in size and strength. A quick question. Can you spot 3 things in your home that might contain magnets? Magnetic and non-magnetic materials. Let's now understand which materials are attracted by magnets. Materials that are attracted by a magnet are called magnetic materials. These include metals such as iron, steel, nickel, and cobalt. Materials that are not attracted by a magnet are called non-magnetic materials. These include wood, plastic, rubber, paper, and glass. For example, a steel spoon will stick to a magnet, but a wooden pencil or plastic pen will not. Understanding this difference is helpful in identifying what objects can interact with magnetic force. Try it yourself. Take a magnet and test it on 5 objects at home. Can you guess which will be magnetic before testing? Now, let's look at an important feature of every magnet: its poles. Every magnet has 2 poles: the North Pole, the South Pole. These poles are found at the 2 ends of a magnet. And guess what? The magnetic force is strongest at these poles. You can even see it when iron filings gather more at the ends. Now here's something interesting. When 2 magnets come close to each other, the like poles, north to north or south to south, will repel or push away. But unlike poles, north to south, will attract or pull together. A mini challenge. If you break a magnet in half, do you get just 1 pole? Or do both pieces still have 2 poles? Think about it, and we'll discuss the answer in next class. So now you know, magnets don't just pull things randomly. They follow specific rules about materials, interactions, and poles. Let's quickly recap what we've learned so far. A magnet attracts only certain materials, not all objects. The first magnets were discovered as natural stones, like magnetite. Natural and artificial magnets differ in their strength and shape. Only magnetic materials, like iron, nickel, and cobalt, respond to magnets. And every magnet has two poles, which either attract or repel, depending on how they face each other. You're doing great so far, and these basics will help you understand the more advanced magnetic concepts coming up next. And with that, you've taken your first step into the world of magnetism. Before we move ahead, here are two simple points to ponder. Do magnets keep their strength forever, or can they lose their power over time? What do you think? And in today's world of high-speed trains and smart technology, do you think magnets play any role in modern transportation? Think about these. We'll connect the dots in our next video. Stay curious, stay connected.